We are Team Farm Pulse, and our problem statement title reads Intelligent pesticide sprinkling system determined by the infection level of a plant. India is the world's second largest producer of food, but every year we lose billions of rupees in crops due to pest diseases and inefficient spraying practices. Farmers often rely on guesswork using excessive pesticides or fertilizers that not only pollute our soil and water but also leave behind harmful residues in the food that we consume. Our innovation AgroPest is an AI and IoT powered autonomous rover which is designed to revolutionize modern farming. So our workflow diagram states the rover will first start. It will sprinkle water to make the plant surface clean. Then it will capture image and it will process the data. If it's detected an infected plant, then it will select the pesticide type and doses, find the spray zone, and it will actuate the pump. If no infection is detected, then it will see whether fertilizer is needed or not by the help of the pH, which is measured using soil NPK sensors. And if fertilizer is needed, then it will spray the fertilizer amount, it will dispense it. All the data will be logged into our dashboard, which can be accessed by the farmer. This is the autonomous navigation mechanism. The farmer will first mark the farm area to be covered on our application. The rover will be placed at the starting point and the rover begins along the plant path. We will be using LiDAR sensor which will detect objects on path. If an object is not detected, then we will continue moving along the path. If an object is detected, then first it will check whether it is plant or not. If it's plant, then it will perform the scheduled operation which I have mentioned before, like sprinkling water, spraying pesticides, etc. If it's not a plant, then it will check whether space is available or not. If it's available, then it will navigate around the object and the rover location will continuously upload it on the farmer dashboard, and if it's no space is available, then it will stop and notify the farmer via the dashboard. Coming to the plant disease detection and login mechanism, the camera module will first capture the image of the plants. Then our ML model will come into action. It will detect whether disease or pest is present and what amount of severity is it. If treatment is not needed, then it will skip the treatment and it will log the plant status and it will update it on the dashboard. If it's needed, then it will determine the action and dose of the fertilizer or pesticide, and then it will just take care of the further process. This is the entire pesticide spraying mechanism, and this is the fertilizer dispense mechanism, as we can see. So it will be done by soil NPK sensors, and this is our prototype model which we have built. So this is the working of the soil NPK sensors which we just talked about. It will be required to detect whether fertilizer need is there or not. So it will measure the nitrogen, phosphorus and potassium value, and based on that we will check whether in the soil some amount of fertilizer is needed. It will be an unique feature in it. So basically we were using this soil NPK sensors, and this is our entire usage. This is our entire data which we will just receive from the soil amount, and based on that we will just dispense the fertilizer where it's needed. Coming to the data flow diagram, we will be using Jetson Nano for sprinkling purpose. Pump, solenoid valve and sprinkling nozzle will be used. For navigation purpose, motor driver and DC gear motors will be used. We will be using soil NPK sensors to measure the pH value and the values of potassium, nitrogen and phosphorus. We will be using camera module, disease detection module or the ML module will be used. LoRaWAN will be used for long range communications. The entire setup will be powered by LiPo battery pack, which in turn will get its power from solar panel. We will be using LiDAR sensor to detect whether an obstacle is present in the path of the rover or not. We will be also using GPS module here. This will be our app interface. The rover can be controlled from here easily by the farmer. So these are the patrol settings, and this is the entire app UI part. We can see that farm dashboard, rover control, health reports, analysis and settings all are available here. We can also see the health reports of the plants yes, as we can see it. Now let's see the analytics and insight section. How much cost is being saved. This is the health and yield trends, and this is the entire dashboard where the farmers can log in and sign up. This is a data set of various crops and their probable diseases which is available online.